We hardly give a thought to the millions of measurements made each day. But what if the clock you depend on was wrong? Would you be happy if you paid for 10 gallons of gas and only got 9? What if the airplane you were flying on had an altimeter that was off by 100 feet? Or what if the cable tester you used to certify a building indicated that the cable failed, but it was actually good? Or worse yet, indicated that the cable passed, but it was actually bad?
We expect measurements to be correct, especially if the tester says fluke on it. Calibration is the process that we use to ensure the measurement instruments are accurate. By comparing measurements against the standard or even better accuracy, we can tell if the tester is performing the specifications. Most people don't know how unique Fluke is in the world of measurement. Not only do we calibrate our own products, we build the world's most accurate calibration standards that are used by aerospace, automotive, communication, pharmaceutical, and national laboratories around the world. We literally wrote the book on calibration. One of the most important aspects of calibration is measurement traceability.
To ensure that everyone's measurements agree, we all need to have our measurements connected back to the same reference or definition. Versiv measures the cable and tells you the result. We designed a collection of custom calibration artifact modules to tell if the Versiv is measuring correctly. We use a laboratory-grade network analyzer to tell if the artifact is accurate. The network analyzer's calibration can be traced back through its own chain to primary standards. It's necessary that every step in this traceability chain is more accurate than the one before. To maintain this measurement traceability chain, Fluke has a primary electrical calibration laboratory at our headquarters in Everett, Washington, that houses some of the world's best measurement capability. We build precision electrical meters that calibrate certain parts of the Versiv modules for resistance measurements. We build calibrators that calibrate these meters, and the reference standards that calibrate the calibrators. The Fluke Primary Laboratory owns some of the world's most accurately calibrated standard resistors, with over 50 years of history, that are maintained in a tightly controlled temperature bath. Fluke is able to calibrate resistors to an accuracy of 0.000017% of their indicated value. That's like measuring the height of the world's tallest building to less than the thickness of a human hair.
Why is this important for cable testing? New standards for PoE, which stands for Power over Ethernet, allows us to provide power and connectivity over twisted pair cablings to support the Internet of Things. These standards require that the resistance difference between individual conductor pairs for some common cable runs be within 0.2 ohms, a very challenging measurement requirement. When your Versiv tester indicates an unbalanced condition, you know it's accurate because Fluke Networks maintains a path of measurement traceability to NIST, the United States National Institute of Standards and Technology, which operates the quantum standards that define the ohm.
Other measurements, such as crosstalk, are traceable to our primary standards laboratory. But our products are so accurate that we own a reference standard made up of superconductors that operate a few degrees above absolute zero, which are based on properties of quantum mechanics, the same one used by NIST and other national laboratories around the world. There exists no more accurate way to source a volt.
Fluke's in-depth knowledge about metrology, the science of measurement, is part of the reason that 31 cable manufacturers around the world have evaluated the DSX series and approved it for their cable testing and warranty purposes. Our people's passion and dedication to measurement is what makes Fluke the most trusted brand in test tools.